So now we'll move on to our second talk this afternoon, and our last talk of the day. And if this is anywhere near as entertaining as the paper, it will be a great way to motivate discussions at the reception next. So we have now James Noble and Robert Biddle, who are going to talk about programming language as language.
Yes, yeah, one of us other than me did. Thank you for that introduction. If it comes down to saying, yeah, you actually have to be drunk to understand our talk, well, it'll make it more fun, I can guarantee that. I have to push the left button. What happens if we push the left button? What happens if you press the right button? If you press the right button, it'll switch off. I pressed the right button. Or was it the left button? No, I pressed the left button. Which button did you press? It's green, that's a good thing. Yeah, I'm holding this so I can walk around. Present it to you. Languages, programming language. It is wonderful. It's almost like a large language model, you know. To quote Alan Perlis, if I ever ask for a programming language where I just need to say, where someone just wants to say what they want done, give them a lollipop. Alan Perlis, Epigrams on Programming. It was in SIGPLAN notices. Anyway, the most highly cited journal in programming languages and computer science. Anyway, as we know, language was invented by Noam Chomsky. Here you see a diagram of the cat sat on the mat. There are noun phrases, there are verb phrases, and prepositions, and determinants, and it's evening, and it's morning, and it's a new day.
And that is why children in primary school, the first thing they must do is learn to build push-down automata. And when their language recognizers begin to work, they start to infer the role of word order and token order in order to build up the trees and recognize the language.
Or as we say, they're just big Elizas. But anyway, different languages, though, different human languages have different word orders here. So for English, clearly, it is natural in the entire world to say the cat sat on the mat. And, you know, for how long was it? 500 years, the British Empire ruled the world with the insistence that anybody who thought the word order should be different was wrong. Or not just wrong, but actually evil. And many of our favorite television shows today are dedicated to this, to that particular view of the world. But in practice, of course, there are all kinds of languages that have all sorts of different word order. So subject, verb, object, cat, sat, mat, verb, subject, object, verb, object, subject. Where things get strange is, and in fact, an awful lot of blood has been spilt and an awful lot of papers have been rejected from Poplar and apparently from Uppsala, although that doesn't seem to happen, at least not for these reasons anymore, over whether you wrote your program with the correct word order. So, for example, I think the first one is postscript or fourth. It's a subject, object, verb. It's, you know, cat, sat, or cat, mat, sat. We say, here's the string, and we're going to search for it, and then we say search at the end. The verb, the name of the procedure goes at the end. On the other hand, Java, of course, well, it's not English, but, you know, some string, index of M is Java, or Smalltalk, or APL have actually the same word order, which is subject, verb, object. Okay, and people are nodding, they probably speak languages that also have this word order, and clearly this is the best one, because that's basically object-oriented programming. What's left for the English? Well, clearly, oh no, it's not really English. Anyway, sorry. Functional languages. What I love about this is that C and OCaml have exactly the same word order. I know there's been a lot of blood spilt about which language is best, but in some ways, if you think about the organization of the program, programs are organized, they're modular programs, very much like Viet's modular, and, you know, they have the same verb order, and Haskell is out on the end. Haskell has this really weird word order where you go verb, object, subject. Because, let's think, I don't know, 8 curry I. Yeah, Haskell, you'd say 8 curry I. Because if you're going to curry your program, you can then apply the 8 curry bit to other people to find out whether they ate their curry or not. Okay?
And so the real story is that in object-oriented programming, the object is the subject. Oh, goodness me. Who did I ask about this?
I don't know, who do you want to ask about it?
I asked
Brad Cox?
No,
He's dead now.
No.
Yeah, Brad Cox is dead.
I asked the king of the small talk world, in fact.
All right. Peter Deutsch.
And the story was...
Alan Kay.
Yes. And so I asked Alan Kay about this, and he said, "Who are you? Get out of my house." No, he said... what he said was that he wasn't thinking of the linguistics terms. He was thinking of biology. And when biologists study their specimens, they refer to the specimen as the object, and hence the biological model of programming was object-oriented. But we can move on from that.
Well, we're going to whether we can or not. If you're English, and if your first language is English as well as for mine, you probably got to ignore most of this stuff unless you were forced to learn Latin or Finnish, particularly Finnish, Estonian, German, and many other languages.
The most important thing is that when you were forced to learn Latin, you learned little word games to remember all of these lists you had to know. And one of the most important you had to learn was this one for noun declensions. Never go down a volcano alone. Or as we say in New Zealand, never go down an active volcano. This turns out to be important advice.
Yeah. And just because even it's New Zealand and someone offers to take you down an active volcano, you know, say no to volcanoes. Right. Anyway, so in Latin, these things, for example, will be typically indicated by the endings of words. I believe there are languages, possibly Hungarian, you learn Hungarian with the lead of speed of summer light, where it's actually the Finnish, probably the middle of the verb or the noun used might actually change depending on whether you are actually referring to the subject. You know, this is a chair, or genitive, my chair. I'm trying to think of this. There's not really an English version for that. Dative, the indirect object, or that chair in English. These kind of things typically happen via prepositions. Oh chair, that would be accusative. Oh chair, where did my USB stick go?
Oh chair is vocative.
Oh chair is vocative, yeah, I'm sorry, I meant vocative.
I learned Latin before you did.
You did, yes, well I never really learned Latin. Now, I know lots of us like the programming languages whose names begin with R, but, you know, really, it has reintroduced the need for precisely these kind of noun cases in our programming language. So if you want to talk about yourself, the object yourself, well, you write and self in Rust. Genitive things in Rust, you just say, well, it's some list, but it could be, well, in fact, that means my list. Dative, you've got to say, we've got to put this list in a box so it can be referenced. If I'm talking about a list that I've got a reference to, again, all those things, vocative for their macros, I want you to print it, and I really don't care about how you do it, and all that functional, you know, the people who say, Rust is a functional language. Well, sure it is if you never write an exclamation mark. But go off and run one of your macros. So those things really correspond to parts of speech. And we can see them in programming languages in as much as we can the natural languages that do these kind of things. Not every natural language does. English does the same thing in different ways. parler ça, ou peut-être...
Well, I was just going to say, in written language, we separate them. But of course, in spoken language, a lot of those things, of this, at this, whatnot, could be regarded as annotations on the words themselves. Because when you break down on the basis of pauses, those often disappear. But in written language, we basically separate them.
Right, and once again, there are lots of language, even English. The written language, which was in the paper, which was written by ChatGPT-3 from the actually it was Otter.ai from the transcript of the talk, a version of this we gave at Hopple a couple of years ago. Just anyway, never mind. A dark period in my life, but anyway. The written language and the spoken language differs. There are other languages, other human languages, where that happens and even more to the case. And so the way that things are written and the way they appear don't necessarily correspond to the way you might say them or the way you might think about them. So, there is, as we say, a European language, which has one word for tower, and the word for tower is le tour. And then it has a word for tourist, isn't it? I can't remember. Tour, la tour. Tour.
One might go on a tour to the tour.
Yeah. La tour. Other way, it's the other way round. Excellent. Good. Someone can speak French. Anyway, right. For English...
No, we're not saying that programming languages should have gender. No, that wasn't the point at all. No, just pay attention.
Well, who knows? I mean, there was a lovely talk by Philippe Hammonds there, and quite possibly for languages, if you wanted to, there is certainly a question raised by several of the talks. If you do really want to suit your language to the end-user programmer, perhaps it's to a student who speaks an indigenous language, how many of these features should you actually intentionally incorporate into your programming language? Because the catch with this gender thing is, or noun classes, because, John McWhorter, a linguistician who is apparently a friend of mine, famously says, yep. Do any of you remember Women, Fire and Dangerous Things? No, you're not that old. Yeah, some of you do. There's a book by George Lakoff, Women, Fire and Dangerous Things, that, basically says, there's this country somewhere, probably Australia, where there's an indigenous language where women, fire, and dangerous things are all in the same grammatical class. You might say the same gender. And John McWhorter says, yeah, right. And then he points out that, yes, that's
made
right.
up that class?
And there is a language there's another language where, the feminine gender is used for things like bridges and railways. Meanwhile, there's another language where an awful lot of the terms of food are masculine and, blah, blah, blah. Okay. Now, the one where all the engineering stuff is it's apparently feminine is French. And the one where all the food is masculine and staunch is German. What does this mean? Well, John McWhorter will say these things are arbitrary. This doesn't actually control the way that you think. You can't really generate assumptions from the shape of a society or the shape of a community or even the shape of a bunch of people using programming languages by what may simply be accidents of the noun class that particular sets of sounds were assigned to when, I guess at some point when the language was being written down first 500 years ago. We don't have noun classes in programming languages, do we? Because, they're pretty annoying. If you're English, I guess this also goes to people who speak Chinese or languages that don't do this so much. It seems really, really annoying. Because the problem is, if you want to put la tour le tour into a sentence, you've got to make sure all the verbs line up so that they're all masculine. Or if you want to talk about la tour, you've got to line up the rest of your sentence so everything is feminine. So we've got these kind of pretty arbitrary categories, and that they sort of infect everything we have to do in our language.
That's what you're talking about.
Close. Well, in fact, I am actually talking about monads. This is the programming language I first learnt from a book called ZX81 Basic Programming. And yeah, if you could, I'm lying, this is actually BBC Basic. If you wanted to make a variable that had a floating point number in it, you could call it X. And if you wanted to make it a string variable, you had to call it X string. And if you wanted to make it an integer variable, 32-bit, it had to be X%. This is basic. in more ways than one. That's a joke I've already used at a different talk in this conference. What does this mean? This means, are you saying BASIC is a statically typed language? But it's interpreted, it's dynamic, isn't it? Well, how can I put this? No. BASIC is a statically typed language, and the types are encoded in every single identifier. So what else have we got? Noun classes. And it carries on there. If we want to do different operations, we have to just keep flowing all those things through. And you can actually look at certain things in languages. So for example, BASIC's heritage in, coming from Fortran and doing mathematical stuff, you can say because the unmarked term here, this is not about arbitrary classes, but actually the shortest term, the term that isn't distinguished, is typically the thing that we want to do most often. So BASIC, the code that handles floats, is shorter than the code that handles strings and integers. And not just shorter, it's shorter in a particular way, which is that it's the unmarked term. But the good thing about programming languages and types?
It's him. It's
him.
Elon, look, we've explained it before. You don't own the letter X. No. Look. Yes, we don't mind if you name all of your children X. No. Okay, and I hear you have more. Yeah, so, congratulations to you and oh, she's now called X2. Oh, I see. Okay. Don't bother us again, Elon.
She's his X. If, languages didn't exist, we would have to invent them. If type systems didn't exist, we would have to invent them. And sometimes when type systems do exist, we invent them anyway. So this is Hungarian notation, Charles Simeoni, and you say that a variable is floating point in order that you can see the FPX in your code. Yes, this was certainly the days before Visual Studio Code where you could just point at a variable and get its... Can you actually just point at a variable and get a magic pop-up of its type? Anyway, but you couldn't do that, so to be sure you remembered that what the type was, you would put the type directly onto the variable. And, it would be sad, but at this point you have to think that this is pretty much the Hungarian dialect of C. Because, if you write code like this and you try and write code leading those things off, people will yell at you, they'll tell you that you're not doing it correctly. One of the first projects, well, it wasn't the first project, one project I hoped to do to send into SIGPAR notices when it was still running and was really disappointed that I never got around to doing was the Hungarian notation checker for Java. Because it seemed really bad if the Hungarian type annotations you put on your variable names didn't agree with the actual declared types of the Java program. It is all kind of pointless, but you could certainly do that because this effectively is a type system, this effectively is another bit of a language, and what's interesting, if you look at the way in which human languages evolve, you can actually see this kind of stuff happening in, quotes, natural languages as well. People will change the way they pronounce words, they will add in various suffixes, they will add in various prefixes, you leave that for a few generations, and then you find yourself with a new natural language that just happened to evolve.
So if you're Australian and your name is John, people will rename you to
Jono.
Jono. And if you're Australian and your name is Jane,
Jingo and Chazzo and Yippa, if you're a cricketer especially. To the point where when I was last in Sydney, there were ads on the TV and on the street for things like, get down to Macca's and get your rego, Jono.
Yep. So registration was masculine, but McDonald's was feminine.
Yep, that is true in Australia, but they're a bit strange. They have too many spiders, I think. How are we going? You're not going to make me sing. This is the slide of Te Reo Māori, the indigenous language of New Zealand, of Aotearoa, I should say, which you may know as New Zealand. And what's interesting is that this has 3 numbers. There is a song, I don't have my ukulele, I'm not going to attempt to sing it. You really want me to sing it, don't you?
And play the air ukulele.
Air ukulele. tēnā koe, hello to one, tēnā korua, hello to two, tēnā koutou, hello to three. More, sorry. Haere mai, everyone. We don't have enough time to teach that, do we?
No, we don't. We don't have enough time for a lot of the things you've just said.
So that is a thing which I was kind of taught at school. Certainly people are taught at school as part of the ukulele class these days. That language has 3 numbers, and syntactically, you distinguish between you're talking to one person, to 2 people, or to some wider things. You know what I'm going to do now, don't you? That's another stupid idea. Especially if you're English, you look at this and think, well, that's kind of dumb. We wouldn't put that into programming languages, would we? We wouldn't, would we? But we did, and what's more, if I phrased the question correctly, almost everybody in this room would say, and that's a good thing, that's great. Who thinks non-null types are good? Excellent, so it might not be 1, 2, and more. To quote, the only reasonable numbers are 0, 1, and infinity, which I believe is a quote from Bruce McClellan's Principles of Programming Languages. It's still a good principle. 0, it's nullable or it's not nullable, 0 or 1. Or maybe if you want to have more things, you have a collection. I'm not sure if Friedrich Steinmann is in the room, but he's certainly done work on embedding this kind of context a little bit further into programming languages so you can do more things with plurals. But yeah, we have these things in our programming languages. We just don't see them because we don't look at them in the way in which we tend to produce other kinds of languages.
So we've got case. We've got something that isn't gender, but really involves a lot of matching, and
Noun
we've got
classes.
number.
We have verb classes. We've got number.
What else happens in natural languages which might transfer to programming languages? I mean, there's a lot of stuff to do with human culture in natural languages. Surely those wouldn't appear in programming languages.
Well, you mean the story of apparently which Richard Feynman tells about his father in one of his books, how he went to Japan as part of the Army of Occupation. No, it must have been after that, but he was using a phrase book from the American Occupation Army of Japan, and he said everyone was really super nice and really just jumped whatever he said. And it turns out, because this was written for the occupying military power, the register of Japanese that was used in this book was the one that would be used by the emperor talking to a peasant. You know, so instead of saying, excuse me, please, would you possibly just check that the camera is aligned? It would be, you peasant, align the camera. Yes, fine. We wouldn't do that in our programming languages, would we? Would we? You know the answer because it's this talk, right? Oh, no, that's the French example. We can skip that. Anyway, French. Anyone do Java?
Politeness.
This is in Java, though. This distinction, the tu-vu distinction, the TV distinction, the I-thou, for those of you who are Oxford Movement Anglicans. If we're really close to an object, to a field, we can just write x equals x plus p. If we're a bit further away, we can write OX, we have to mention the name of the object. Why? Well, I could give you all kinds of computer sciencey reasons for it. But linguistically, it's like, well, you know, we're closer to the object, and so we have to, if we're really close and intimate with it, we can speak quickly and rapidly, and the further we are away, if anyone, they're not called Enterprise Java Beans anymore, because I think Sun was ashamed of them. I think they're now called Jakarta Enterprise Beans, but the abbreviation is still EBJ. You ever had the misfortune of programming in them? You get to be, the people who are nodding, you have to be extra polite. You can't say just x equals x plus p. You might have to do something like this with all these kind of accessors. And anybody who knows, you know, again, there are software engineering reasons for this. There may be good reasons for it, but fundamentally, it's not really doing any different to what the top line of the slide is doing, except it is doing it in a different register. It's doing it, you know, with a lot more characters, and this is one of the reasons why apparently lots of people in the real world think Java is basically a kind of fucked up language.
I thought you were going to say corporate language.
I did.
I think the alternative for enterprise Java beans was imperial Java beans. I think they rejected that for a good reason.
I did say fuck. I'm not in America. I figured I actually lost. Jan Vitek told me I once lost a job offer by swearing out of class in America, but I'm not in America. But you wouldn't swear in your programs, would you? Especially not if you're a Haskell programmer. If you think that you would never swear in your Haskell programs, I encourage you to go and read what the Haskell language manual says about unsafe perform I/O. You know, it is exactly what a phrase book for someone coming from outside to English might say, because, you know, well, we really do need to, the tourists do need to understand what happens, especially in Texas, if someone tells them to fuck off. Because if they don't understand it in Texas, they could be shot. Okay? You really have to understand what this means. But also, again in Texas, and especially if you're a tourist and visibly different, you don't want to use that, because you might get shot. So the guidebooks basically say, here is what this thing means, here is what it does. You should never, ever say this. But this is what it does. That wording, almost without some of the hyperbole and slightly more Anglican once again, is what is in the Haskell standard about unsafe perform I/O.
Couldn't they have said unclean? Don't you think that would have transmitted the message?
We all know that's what it means.
Right. So that's the operational low level. That's the level at which
Thank you.
we start at. But we want to go up in the level. And this means we want to think about programs as a whole. So if you're an outsider, if you're one of the people who's contemplating end-user programming, or if you're one of the people basically reading a very introductory article in the news, you might have an explanation of what a program really is. And these two come from the OED. A program is a sequence of operations that a machine can be set to perform automatically. Or it's a series of coded instructions and definitions, which when fed into a computer, automatically directs its operation, performing a particular task. So, we've been programming a long time. We've been programming at least 4,000 years. And this was a point made by Knuth in his wonderful paper on ancient algorithms. So, clay tablets, like the one at left, which were produced in abundance 4,000 years ago, typically encoding the Akkadian Sumerian language, certainly at the time, for instance, of Hammurabi coding his laws that were given, you can go and see in the Louvre. Basically, aside from setting laws and horrific punishments for those who break them,
and
they typically encode relatively simple things in the operational world. And this particular one, Knuth is aided in translation from Sumerian Akkadian, which was the sort of lingua franca, actually technically the Sprachbund, the federated language of more than one language, in fact as many as 4 at the time, said things like, when you are digging a well, in order to basically find out how deep to dig it or how much water it's going to store, you should take the reciprocal of the height, 320, obtaining 18, they worked in base 60, multiply this by the volume, 274640, obtaining 820. Now, Knuth says this is an algorithm. The title of his paper is Ancient Algorithms. Now, am I allowed to disagree with Knuth?
No. You're going to anyway.
Yeah. Well, this is enemies I've made. Number 1, Alan Kay. Number 2, is Donald Knuth in the audience? No, I hope not. So he says it's an algorithm. I say it's a program, because it's really very specific. It's literally a set of instruction. Now, presumably, the people who read this weren't always going to dig exactly the same size well. But this was an example from which one would learn. So I'm going to say this is a program. My point is, we've been programming a long time, and those are instructions. Now, at At the time, the only people, the only things, the only entities worth giving instructions for were people. But when we started having computers, we thought of basically how to give instructions to computers. And so this is Seymour Papworth's logo. In fact, it's turtle graphics. I taught this to primary school students many years ago in New Zealand. We didn't have one of those actual physical turtles. We made do with a little triangle on a screen. But the thing is, these are instructions. A program here is instructions. In order to make a pedal, this is what you do. In order to make a flower, this is what you do. So, as the OED says, we do have programs that are instructions. But we sometimes want more. So, for instance, in COBOL, if you're programming back in the days of the Johnson Wax building there on the left, you will have something which will be very much instructions, here as in the procedure division at the bottom, but an increasing amount is also spent on the data division at the top, where you describe the records that you're working with. And COBOL, a common business-oriented language, was working with records almost all the time. This is what it was for, and this is what it is still for, and is still used now in 2023. So now we've got a bit more. It's not just instructions, it's descriptions and instructions. But I think a change happened a bit here. So this is similar, and I learned similar from Graham Birtwistle, and it was the era of that book over there. And similar starts to look like this. So it's talking about a car washer. And basically, it's a description of the life of a car washer. Now, this car washer doesn't have a particularly exciting life. I understand real car washers have much more entertaining lives. But here, this says the car washer basically repeatedly waits for a car to be washed, waits for it, and when the car is washed, basically moves on and waits here in Graham Birtwistle's example of the tea room. So, in reading these kind of programs, my claim was that this was more like a narrative. This was more like a story. We were talking about the life story of a car washer. So what I'm saying is, this is a bit different from instructions and description. And we moved on. And at this point, I want to invoke some early discussions of the way stories are told. And there was a lot written by Socrates, although we only have this through Plato and Aristotle, and by Plato and Aristotle themselves. In the painting by Raphael, Plato there, the senior, on the left, and Aristotle on the right, had this argument over time between two different ways of telling stories, and they were mimesis and diegesis. And the idea of mimesis is that it's imitation, and the idea of diegesis is that it's a storytelling. And the argument began with Plato, who was strongly against, in ancient Greek theater, mimesis. He regarded it as problematic that someone pretended to be someone else, that it imitated something that it really wasn't. So that in the Republic, he regarded this as a kind of deception that was necessarily bad. And so following up some years later, in the Poetics, kind of criticism by Aristotle, he makes the point that in the theater, mimesis has a point, because when actors are imitating, one begins to empathize with the actors. You understand a bit more of the thing from their point of view. You begin to understand their intent. And so Aristotle says that mimesis has a place, and we don't just want dispassionate narration. And at that point, I began to think of my claim that object-oriented program, a la Simula, was just a form of narration. And it occurred to me that in writing, back in the late 80s, early 90s, this was talked about a lot. So in this paper, we talked about the nature of an object-oriented program, and so Christian Nygaard was this, so I will pass over to my colleague who is a Nygaard laureate.
A program execution is regarded as a physical model, simulating the behavior of either a real or an imaginary part of the world.
And so when we think about creating these models, one of the influential papers is this paper by Kent Beck and Ward Cunningham, a laboratory for teaching object-oriented programs. So this is the birth of CRC cards. So that when you're generating a design, and this is some of our students, James and mine, back in the day, you start by thinking of the objects in the domain, and you start walking through what needs to be done, what these days we would call use cases. And the way you do it is that each person takes a card and pretends to be that object. So this is clearly mimesis. You act like it, and basically this is what goes on, for instance, in table reads in Hollywood and theater. No one is wearing costume, no one is blocked and walking up at their mark. One simply walks through the script pretending who you are. And the reason that they have table reads is that so that everyone can understand the interaction, everyone can get into the simulated world. And this is exactly what's going on, we claim, with CRC cards and CRC roleplay. So we claim that this is mimesis as well as narration. Which leads us to this famous book, or the follow-ups that we think should have been existing. Nicholas Verrett's famous book on the left, Algorithms plus Data Structures equals Programs. Gosh, that's almost a program in itself. Don't you think it should be Algorithms plus Data Structures is assigned programs? Or, what was that language that we learned about earlier on today? BOSC? Yeah. Basically, algorithms lead to programs. But you think that the book should be rewritten for today?
Well, it could well be. Well, it's a great book. You can get it online. But he deleted the equals programs from the book. Yeah, but Nicholsworth clearly verbs plus noun phases equals stories is what we could call it today. The Prentice Hall steric and autonomic recitation. And its systematic and lucid and penetrating treatment of basic and dynamic story structures such as sorting, recursive narratives, language structures, and plotting.
So this is our claim. Programs are really stories. Even functional programs are stories. Even in natural language, look at the works of Virginia Woolf, look at the world of Emile Zola, there are programs, there are stories that don't necessarily have plots or side effects. Oh, this is my line, isn't it? Yeah, if it wasn't for side effects, we'd have no effects at all. Right. So we think programs are stories. Now, if they are stories, we have things to learn about stories. So this is the work of the narrative semiotician Grimas, and he talks about models of stories. And one of the models he liked is based on these actants, as he called them, and he talks about a standard template for a story involves a subject trying to accomplish an object, there's those words again, but typically, to make a story more fulsome, more elaborate, the subject will be sent on a mission by a sender, will receive help from various aides, and that the object is often to satisfy a receiver, but importantly, in typically stories, the accomplishment of the object is impeded by an opponent. And this is a typical model. So our question is, are programs like this? What do we have to learn from this? Do our programs have opponents? Do our programs have helpers?
Sadly, yes, I think they do.
And so the important thing, if you're a writer of a story, is to understand your toolkit of actants in this, and we think that we might learn as programmers in understanding this. Now, going a bit further, this model in discourse analysis, done by Van Dyke, discourse linguistics research, and in fact, the person who chose the word discourse, basically, along with Kinch, talks about stories, about all discourse, in fact, being related to a more abstract model. And they call this abstract model a situation model. And their point is, for instance, that this is what's going on when novels, when poems can be translated from one language to another. It's not word for word, it's not grammatical. Basically, in understanding a story, they say, one forms a situation model, and then from the situation model, expresses the best they can in another language. And so this is a model of translation, but also a model of understanding. And much more recently, another discourse analyst and a psycholinguist, in this case von and Radvansky, do empirical work, and they say that there are 5 dimensions involved in making this work. And this relates again to papers I've seen presented today. One is time, one is space, another one is causation, fourth one is motivation, and basically there's the actors, the protagonists. And so what they're claiming is, this is the software that we use to both create and understand stories. And so if we're right in claiming that programs are stories, maybe we have something to learn by these being critical elements in creating and understanding stories. And the question there is, what leads to this? And our line here comes from other linguistics research. So this is Clark and Wilkes-Gibbs going on at the same time. And they emphasize conversation. So this is a line from one of their key papers. Conversation is the fundamental site of language use. For many people, even for whole society, it is the only site and the primary one for children acquiring language. So basically, you've probably learned that spoken language, audio language, precedes written language, and their claim is that conversation precedes storytelling. Conversation is interactive. This is the genesis of language. And so we thought, ooh, if programming languages are languages, how does conversation work? And we thought, what programming is like a conversation?
So this is an actual picture of me, but live coding, if you've come across this. I do actually do this from time to time, occasionally even for money, with either a laptop or a modular synthesizer, where I will sit down and perform generally sort of no-wave, noise-based, I'm not going to say music, but audio, sound art, yeah, which you do basically by coding and as a performance. But then, I mean, I don't think that's the only kind of live coding we have. When I was teaching Daphne, which, well, you know, if you want to find out about that, come and buy me a drink afterwards. We actually taught Daphne fully live coding in classes, because we flipped the classroom, we pointed people at Ruston Lino's book, and we had 120 third-year students who couldn't fail the course without doing an extra year on their engineering degree. And we would basically give them Daphne problems, and then they would come to the class, and I would live code in front of them with Daphne and swear at it and have all the kind of fun experiences you have in this sort of thing. And then students would submit their assignments, and when they got their assignments, the assignment system would basically automatically test it and give it back. And so these kind of techniques aren't just for formal systems like Daphne. There's now quite a bit of research showing the advantage of having rapid feedback from a kind of system when you're teaching people to program. Why? Well, if programming is conversation, then maybe we need to have those conversations when we're learning to program. Do you want to talk about that?
No, I'll take over.
Oh, I'll do the next bit then. Here's another conversation. I don't know if anyone had this conversation. This is a conversation I don't particularly relish. This is my conversation with the Rust compiler, because, you know, the Rust compiler is kind of opinionated, and you're not allowed to have parentheses around your ifs and your whiles. Why? Well, because if you're more than 30 years old, and if you've basically learnt to visually search for if and while statements by looking for the keyword followed by the parenthesis, you're clearly too old to learn to program in Rust. It does have very good error messages. It's sort of like ChatGPT 3. It's really good at apologies. And again, when you think about it, if programming is a conversation, then maybe being good at apologies is important because it keeps the conversation flowing. What are we going to say about that?
But in fact, every REPL is a conversation. The reason that we love REPLs, I program in R a lot, and basically in my data analysis, I do a lot of exploratory things. It's certain that I write code, but I spend a lot of time in the console basically playing off. What if? What does this data look like under these conditions? What happens if I run this test? What if I filter out these pieces of data? REPLs, read, eval, print loops are wonderful for this. But in fact, they go further. This is perhaps my favorite programming ever. This is the work of the wonderful Adele Goldberg in her system called LearningWorks. Used for, I think, what was, at the time, probably the largest introductory programming course in the world, done by the Open University in the UK, who used this system. And her system here facilitated a REPL. Yes, it had a console, but you could do refactoring. You could do substitution. And so basically, the console was how you built up your program by taking bits of what you typed in, saving that, and parameterizing it and turning it into functions, and you're creating your program in this way. In other words, you had a conversation that built the story, and this is what we love. So our claim here is that programming is conversation, and that's how we make up the stories. James, it's 5:30.
Is it? Oh, we need a drink. I need a drink.
Should we stop here and invite questions?
Sure. It's kind of like if you've ever been in a band, you always want to do this so that you can. We can send it to the funding body and say people came to our tutorial.
Yeah, it's useful to have for the police inquiry later.
I was going to be referring back to not Colin. Was it Colin Gordon's talk? But I really shouldn't. You know what those things that Knuth had?
I think you're just trying to avoid Marco's question.
What's Marco's question?
I thought you were calling for questions. So.
Yeah, we're calling for questions, but I'll just wind up and keep going, until I collapse otherwise.
You have lost an incredible opportunity to mention the best name type ever, an exception type in GWT. What a terrible failure.
Yes, there were lots in the programming language originally called AEH, a Canadian language, that later was rejected for publication, but was largely the work of Dave Cheriton, after whom the whole
computer science department is now named.
Yeah, that's right. They had puns, and so they had twits, they had puns, and they had errors. So puns were basically type conversion, because one thing could have two different types, and that was basically a play on words. Twit was the window into trouble when you basically just needed to get at machine code, and errors and that was all done so that basically at the end of your program it could give you a result as how many twits, how many puns, and how many errors, because Sharon was a baseball fan. Someone other than Marco, please. The first time we gave this talk, what everyone wanted to know was, so what? What are the takeaways? Now, in New Zealand, takeaways means...
Takeout.
Takeout.
Macca's.
So,
in Australia, it would be Macca's.
Yeah, so James brought in fried chicken to show him what our takeaways were.
So we got the takeaways. Yeah, Kentucky Fried.
Okay, so there are good conversations and there are bad conversations, and there are good programs and bad programs. Can you talk about the relationship? What can we learn from conversations to write better programs?
So the one thing about conversations, and this was one of the points that Clark and Wilkes-Gibbs was talking about, is that they not only allow, but encourage participation. So if you need to know more, if you want to explore, if you want to check your understanding, basically conversations are great for this. So when you're reading a story or telling a story to a small child, you learn very quickly that it takes several minutes to read every sentence because you have to answer questions like, what was the name of the bear? Why did the bear like the honey? Is this the same bear as before? Where is the bear going? Does the bear spill the honey? So it has clarification. So we've talked about this, and we've actually seen examples of this today. So this is one important thing about conversation. Conversation allows clarification. The other thing, which is a little bit more sophisticated, is that conversations are epistemic. In other words, in that conversation, you can reframe what you're talking about. There's basically famous work through this throughout science, where basically you take opposing positions with one of your colleagues in order to figure out basically what could be going on. Now, you have to be very disciplined in this. Basically, you can't swear and start throwing at things, but conversation has this epistemic thing. So those are two values of kind of good conversations that I'll give. I think the good and bad programs as stories, my best answer for that is remember what the discourse analyst and linguistics talk about the understanding of stories. Now, it doesn't always mean when we're doing literary stories that you want to make it easy for the reader, because actual writers are basically telling stories in order to achieve various kinds of effects. So you're probably familiar with things like unreliable narrators, where basically they are telling you things which later turn out to be true, but this has an effect. Now, whether we want effects like that in programs is worth considering, but it's also worth considering where we're doing that by accident. In other words, there's a lot of knowledge about telling stories which can be super useful to us, and that's our claim there.
Yeah.
So this is a bit of a meta question, but I guess some people in the audience would say proofs are programs. So does this give us any insight into how to better frame and present our proofs that we write down in these papers that we ship to these conferences?
So James mentioned the earlier book by Lakoff, Women, Fire, and Dangerous Things. So I'd actually refer you to Lakoff and Nunez's more recent books, where basically they claim that mathematics and mathematics notation itself is embodied in the same way natural languages are. So in the logic in that book, they would claim also that the proofs are stories. And in the same way, for instance, we have languages now where you can change the order of lines and accomplish the same effect. And that's often true in a lot of mathematics. But the question is, you don't do that when you're writing a program or writing a proof. You carefully present the proof in certain orders, and the question is why, and that will give us insight as to how we can be writing our proofs in order to be more understandable, in order to help us reason better.
Yeah, what would I say? I probably agree with everything there, and say, for better or for worse, I think, well, as things like ChatGPT or things like Z3 get better, then increasingly that is coming to the point that, you know, in some sense our programs really are proofs. Also, of course, as computer scientists, we're eating mathematics. So, you know, in 20 or 50 years from now, proofs will be programs. In some sense, proofs really are programs.
They are now.
They are now, especially if you're trying to get your paper into Popple, frankly.
Yeah.
You know, you can't get it. If you haven't got the cock or whatever it is, then, you know, it's like, well, send it to Uppsala and let it get 1,000 citations or something.
At the Dynamic Languages Symposium yesterday, I really noticed how many times several people talked about the expressiveness of dynamic languages. It reminds me of what mathematicians say, and I was first educated as a mathematician, which is the elegance of your proof. I'd like us to think a little bit more careful about what those words like elegance of a proof or expressiveness of a language actually mean. Because although we have some insight, and we've used those words for centuries, if not millennia, we need to think more carefully and basically read the work of some of our humanities colleagues to basically understand better what's really going on there. because basically we're hand-waving when we just use those words and assume we completely know how they work.
I mean, if we really believed that programs were proofs, that would mean every program was a proof, not just every COP program, but every program. And it would actually mean the question then is, well, what's it a proof of? Which, under that Hakai hierarchy, comes out of, well, what does it do? And, you know, I don't want to say these are the kind of things that quite possibly ChatGPT-4 will actually do for us. But I think thinking if programs are proofs and proofs is piles and piles of functional COC code, it's like thinking, well, programs are machine code. And, you know, instead of ChatGPT, wouldn't it be great if we could write? Wouldn't it be great? You know, I was just thinking we've got to automate our finance department and we've got to write all those programs. Wouldn't it be great if we could describe what the records were and kind of describe what the processing was in a way that the managers could read it? Okay, which of course is what Grace Hopper and Joan Summit done when they designed COBOL. So there's this distinction between the program as the high-level thing which we read and the machine code. And in the same way, I do not ever want to have to look at machine code if I can possibly avoid it. I don't really want to look at the fine details of the proof, and for precisely the same reason. Not because it's a proof or a mathematical, just it's a really low level of abstraction.
When I think of, the reason I included the picture of the Johnson Wax building there with rooms full of clerks is that the language that COBOL imitates was very much similar to the language at which the processes or the procedures that clerks should follow were given to them when they started. In other words, where you started as a low-level clerk in a program, you would have a list of the procedures that you followed in order to process the records. So basically, it was a direct imitation because basically, before that, the managers were programming the employees. In talking about the consistency, in talking about the proofs, the question really is consistency. Now, at a conference like this, we're great about consistency. All of the type theory is largely about consistency, and it helps us enormously for the consistency checking things that we were talking about. But while it's great to know that something is consistent, you still have to look to see whether the thing that it's consistent with itself is consistent with what was needed in the domain. And eventually, you run out of formal notations.
So my guess to answer the questions from the previous session and finish my talk from yesterday is that a world where we do have all this AI stuff, because in fact we already do have a hell of a lot of AI. I mean, what's behind Daphne 20 years ago, SAT solvers, SMT solvers, all of this stuff was AI. What a JIT compiler does is AI. We just don't call it AI because, I don't know, we're aesthetic and we don't like the funding, basically. But something that Hotspot does, if you think about the kind of analysis on complex knowledge-carrying correct structures that something like Hotspot does, well, if it's not AI, then what is it? Oh, it's just all these little rules that run around. Well, it's still more sophisticated than perceptrons. Sorry. I think the world where we have that is going to look more like the world where you were programmed in Smalltalk or COBOL than it is where you are super, hyper mathematical, for exactly the same way that the world we want to build is this world where you are operating at the kind of level we're talking about. You're operating in this language, and this language is designed to let you express the things you need to say, express the stories that you want. And, you know, whether it's the compiler people or the proof people, all that stuff happens under the hood.
Under the bonnet.
Under the bonnet, sorry, yes, under the bonnet. Yes, you've been very patient as well.
Thank you. A very stimulating discussion. When you presented your conversations, they were, I think, effectively dialogue, two-party conversations between you and the compiler or you and the REPL. How would you generalize that to a multi-party conversation in this analogy?
Well, obviously it would be by multi-party session types supported by separation logic.
Yeah, I'd like to point out that that's actually a difficult problem even for humans in natural language. But we have ways of doing it with different groups of people. It's complicated. There are study methods for doing it, but it requires great discipline, in my experience of roundtable epistemic discussions. Richard Feynman talks about that too, right? He talks about some of the managers basically staying out and writing down all the sorts of key ideas, even when people disagree, and then come back to get agreements on them. I mean, the problem is, as I talked about the epistemic conversations between people who play devil's advocate, basically part of the regime is that you have to be willing to let go. This is the kind of thing that as scientists we get better at, and our politicians, unfortunately, don't seem to have learned the trick of doing.
Well, it's worse, but that's another talk.
Yeah.
You know, remember all that stuff that...
Is the reception started?
Yeah, the reception is about to start. You know, all that stuff that was banned. In fact, it probably is illegal to teach in Texas. You know, French philosophy and the idea that everything is relative and that there is no objective truth. Well, it turns out, of course, that a whole bunch of political hacks were listening. Sorry, I shouldn't make these sort of comments. There is a talk on postmodernism and relativism in computer science. That's not it. You can find it on YouTube, where you should give us a like. If you're watching this on YouTube, you should give us a like, and you should click subscribe on the Sigplan ACM channel. And you should come to Splash next year in Pasadena, where it's being organized by Alex.
Yeah. You know, when our talk began, I looked to see, and the subscribers are listed as everyone in ACM, which I think was something like 300,000, and the people actually watching at the beginning of this talk was 8. I hesitate to think what it is now.
Thank you for your time and patience.
Yes.
I understand there is actually food at the reception. There may even be spiritus liquors, as well as just high sugar drinks. I'm around, I think Robert and I are both around for the next couple of days.
Yeah. Thank you for your patience
Indeed.
with this chaotic talk. We hope there was some value for.
Thank you.